all of you are safe and healthy. From now on, we are continuing our lectures as an online course. For this purpose, I will provide you video tutorials for our lectures. This one will be the first one, so we will continue where we stopped. We will start with chapter 4 of your book, where we will consider the personal requirements in planning facilities and design. I will try to explain the materials in these video tutorials, and I will try to keep the size of the videos reasonable so that you can download or you can watch online. We will also make discussion hours, and we will, if you have any questions, you can just communicate with me and I will try to explain you. I believe we will manage to continue with our course in a smooth way. So if you have any questions, any parts that you don't understand, please feel free to contact me. So let's get started with the chapter 4, personal requirements. When we talk about the personal requirements, in fact, we are considering what kind of designs, what kind of requirements regarding the personnel working in the facilities should be considered while designing these facilities. So we can talk about the parking spaces for employees, how to design, where to locate, what should be the size of the parking spaces, and etc. Then we can consider the storage spaces for employees' personal belongings, the locker rooms, what should be the size, where should they be located, and etc. We should consider the restrooms, the number of restrooms, their places. Again, we should consider, and as another fact, the food services that we should provide for our personnel. The health services, whether either it's being emergency or regular health services, how to design these services, what should be the size, what are the minimum requirements for these. Also, for the handicapped persons, how can we design a facility to satisfy the requirements of these people? Also, we need to consider the office facilities planning for the facilities where the personnel works in offices. How to design this is also another issue that we will talk about in this chapter. Many companies have their own philosophies relating to the personnel. So depending on these philosophies, the designing of personal requirements can be different, and that's why it's also the most difficult to plan. Let's see some of the philosophies that the companies may have. For example, a company may say that our firm is responsible for all our employees from the moment they leave their home until they return. So if the company has such a philosophy, then the design of the facility for satisfying the personal requirements must cover every aspect from the time the employee leaves their houses until they return back. Okay, the service planning, the planning for parking spaces, every aspect must be designed critically. But on the other hand, another company may have their philosophy as employees should earn their parking locations, which means that this company does not satisfy parking location for all of their employees, but only the employees which have higher rankings can have these parking locations. So the design of the facility with such a philosophy would be different than the design of a facility from the first alternative. Another philosophy can be this: employees spend 1/3 of their life within our facility. We must help them enjoy their working here. Okay. Again, this is a philosophy, and a company having this philosophy must design its personal requirements, its facilities for these personal requirements accordingly. So let's consider other alternative philosophies. A happy worker is a productive worker. So while considering these philosophies, think about how the design should be changed or will be different from the other alternatives. Okay, another philosophy may be this: a hot lunch makes workers more productive since it supplies them energy. So a company with such a philosophy will pay more attention on providing food services for their employees. Workers who do not feel well are unsafe workers. We should provide medical care to maintain health. Okay. Again, this company stresses the health services, and their design for personal requirements should include health services. Our company has an obligation to our personnel. We will make out facilities ADA, American Disabilities Act, or Local Equivalence Act, compliant. Okay, so these companies stresses the personnel with disabilities, and they design their facilities accordingly. So any company may have their own philosophy, and the design for personal requirements differs for each of these companies having different philosophies. As I said, one of the personal requirements that should be considered is the parking spaces for the employees. In order to design a parking space for the employees, we will follow the following steps. But first, we should make an observation. In fact, these parking areas for the employees' cars is very similar to planning stores or warehouse areas, because you are basically storing the cars for a temporary time in a space. Okay, so basically the design procedure for parking areas is similar to the design procedure for stores and warehouses. So what are the steps of the procedure while designing these employee parking spaces? The first step is to determine the location of the parking lot. By the way, we will consider the steps of this procedure in more detail. First, I want to give you the general steps, then we will talk about their details. Okay. The first step is to determine the location of the parking lot, where you should locate your parking lot. The second step, after deciding on the location, you need to decide on the size of the parking lot. And in order to decide on the size, you should know how many automobiles, how many cars will be parked. So determine the number of automobiles to be parked, the second. And using this information, then you will be able to determine the space required for each automobile, and then you will combine the number of automobiles with the space required for each automobile to decide on the total size of your parking space. Then, when you have this total size and the location, you need to determine the layout of the parking space. We will talk about basic types of layouts, and you should determine some alternative parking layouts. Of course, it depends on the size as well as the available space. Then, among these alternative layouts, you need to select the best layout that utilizes the space and maximizes employees' convenience. The first step of the procedure is to determine the location of the parking lot. Of course, this depends on the available space. For example, consider our university and the campus. So we have an available space, and if we want to establish a parking space, then you need to consider the size of the campus, the existing buildings, and then you should you can talk about the parking spaces. But there are some criteria that you need to satisfy. It's a common rule that the employees should not be required to walk more than 300 to 400 feet from their parking place to the entrance of the facility. Of course, it may depend on where you are. For example, if you live in a country which is very hot, like Oman in summertime, or very cold, then you should think about these numbers, and maybe you should try to reduce it even more. Okay, so but as a common rule, as a rule of thumb, none of the employees should walk more than 300 to 400 feet from their parking place to the entrance of the facility. Again, also, if there are multiple parking lots, again in our university, in our campus, there are multiple parking lots. The entrances are needed in order to accommodate employees. So if there are such entrances, then employees should be assigned to specific lots and entrances. Again, you see in our campus there are different parking lots. Some of these parking lots are allocated for students and some of them are allocated for faculty members. As a faculty member, I cannot use every parking lot because also the space allocated for faculty members are assigned to different faculties, different departments. So as a faculty member in the mechanical and industrial engineering department, I can only park to two parking lots that are allocated to our departments. Okay? And these are the most the closer ones to our department so that we walk less. The next step in the procedure is to determine the number of automobiles to be parked. Again, we can use some rules of thumb to decide on. Also, if you have the necessary data, you can use that data. Depending on the availability of public transportation and the use of the staff of this public transportation, you should decide on this number. For example, if we are talking about a remote site which is not being serviced by public transportation, then we may need a parking space maybe for every 1.25 employees. So the employees will be using the parking spaces more if there is no public transportation. But you may ask, why not one parking space for each employee? Because it may be the case that some of the employees have their leave times, annual leaves during that time, or some of the employees share the same car, or some of them come to the site by walking or by cycling, and etc. So not every employee will come to work every day with their car. That's why 1.25 can be used. Or if we are planning a site which is being sourced by public transportation, then a parking space may be required for every 3 employees. But of course, this also depends on the local culture. For example, here in Oman, even if there is a public transportation, people used to come to work with their own car. Okay, so in that case, you should think about this number and you should find accordingly. Again, and as another example, in Turkey, the companies provide employee services, transportation to the facilities in the morning and in the evening. So usually many of the employees use these free transportation services. That's why the number of employees coming to work with their cars is less. So in that case, instead of considering one for 3 employees, you can even reduce this number and you can consider one parking space for 5 or 7 or more employees. For handicapped parking, you should pay more attention. Again, as a rule of thumb, it's said that for every 100 parking spaces, you need to allocate 2 to 5 handicapped spaces. Of course, if you know the number of handicapped workers in the facility, you can use that data, but also there may be regulations with the local or central governments so that they should force you to allocate certain number of parking spaces for handicapped people, and you have to allocate at least that much that many spaces. And as I said, if the philosophy of the company is to serve these handicapped people more, then in order to serve this philosophy, you should maybe allocate more parking spaces for handicapped people. Next step after determining the number of automobiles is to determine the space required for each automobile. Of course, you cannot know how many different types of automobiles are being used, and also even if you have that information for now, after 1 month, after 6 months, that information will be changed because people used to sell and buy new cars, new types, and etc. The size of the parking space depends on the automobile type, whether it's a small car, it's a saloon car, it's an SUV, and etc. But usually this size of a parking space varies between 7 by 15 feet to 9.5 by 19 feet. Again, this depends on the automobile type and also the clearance that you need to provide. Okay, the clearance is the space around your car so that you can get into car or load and unload the bags and etc. into your car. So some clearance must be allocated for each car. To determine the space required for each automobile, you can consider the type of the car as well as the facility, the purpose of the facility or the purpose of the parking space. What is it serving for? Okay, so when we consider the width of the parking stall, then if we have, for example, a small car use, then you can allocate up to 8 feet of stall width. For all-day parker uses, then it can be between 8 to 8.5 feet. For standard car use, it can be from 8.5 to 9 feet. For luxury and elderly use, it can be from 9 to 10. So what is different in luxury and elderly use? You, for example, allocate more space so that these elderly people or you are satisfying a luxury use so that people get into their cars easily, they can open their doors up to the end and etc. For example, for supermarket and camper use, it can be 9 to 11 feet. Okay? And for example, for handicapped use, it can be 12 feet so that these people can get into their cars or take off their cars easily. Again, depending on the regulations of the country, of the government, you may need to allocate certain number of parking spaces for handicapped use. So these are the recommended range of stall widths for different uses. Of course, while making your designs, you can make use of such tables and such rules of thumb, but also you should consider the local culture, the local philosophy of the company, and etc. Again, in different sources, you may find different rules of thumbs, different regulations, or different suggestions for allocating parking space. So this is another example. With respect to different organizations, uh, how much parking space should be allocated. So, for example, if we are considering a restaurant with a drive-through facility, it says that you should allocate one parking space per 75 square feet of floor area, or 1.5 person. For each 1.5 person, you need to allocate a space, and you should select whichever of these two alternatives is larger. You see there is a different metric here. It asks you to allocate a parking space per the square feet of floor area that you have. Not only how many persons, you are also considering the size of your floor area. For example, if the organization is a theater, arena, or an assembly area, then it says that you need to allocate a parking space per 8 feet of bench length, the sitting area length, or 4 seats, whichever is greater. So one space for 4 seats or one space for 8 feet of bench length, and you should select whichever is greater. Okay. Again, you can consider different organizations, for example, secondary schools and colleges, factories, hospitals, churches, hotels, and warehouses. Depending on how people reach to these facilities and what these facilities serve for, the amount of parking space that you need to allocate changes, and these are some guidelines for you. This is another example for allocating space for people with disabilities, and it says that, for example, if the total space in the parking lot is in between 1 to 25, then you need to allocate at least one parking space for disabled person. If your total parking space is between 26 to 50, then you should allocate two. So depending on the size of your parking space, the amount or the number of parking space assigned for people with disabilities changes. This is also another source, another table that you can use in your design. After determining the location of your parking space and determining the the space that you need to allocate for each automobile, and the number of automobiles, the total parking space to be allocated to these cars, the next thing in the procedure is to determine the alternative parking layouts. And in order to determine this, a number of factors need to be considered. What are these? A factor that you need to consider is the percentage of compact automobiles to be parked. If you have the data of the employees having the number of employees having small cars, then you can use that data. If not, again, a rule of thumb says that use 33%, allocate 33% of the total space to small cars. But this depends on the local culture as well. Because, for example, in Oman or in this region, people used to have larger cars. So instead of allocating 33%, you can allocate a smaller percentage for smaller cars. On the other hand, increasing the area provided for parking decreases the time required to park and depark. So you will have more available space, and people will find the space easily and will park easily. Okay, so this is another factor that you need to consider. The next factor, you should understand that if you have an angular configuration for your parking spaces, this will allow quicker turnover. Okay? So we will talk about this in the following slides. But on the other hand, if you have a perpendicular parking space, then the space utilization will be greater. Okay, you will allocate less clearing space, less space for turning, for maneuver of the cars, of the vehicles. Also, another factor that you need to consider is, as the angle of parking space increases, the space allocated to aisles also increases, and this reduces the utilization of your space. Okay, in determining the alternative parking layouts, let me first show you some different configurations. You see here we have in fact have four modules. This first module is the so-called single loaded wall-to-wall. Single loaded means only on one side of the parking module we are parking the cars, whereas this one is double loaded. You see the aisle is in the middle and the cars are parking on two sides. So this is a single loaded module, but this is a double loaded module. Okay, so these are also double loaded modules, but on this side of this module we have a wall, whereas on this module on both sides we don't have these walls, and the clearance area between the parking space and the walls basically makes a difference between these two modules. Okay, so we have single loaded or double loaded modules, and depending on whether you have a wall or a walkway in between these parking lots, the size changes. Also, we will consider the angle of parking, and basically when we say this angle, it's the angle of the parking stall with this curve. Okay, so this is represented by delta, and if this delta is, for example, 90 degrees, it means that you have a perpendicular like this parking space. But if delta is positive, then you are parking at an angular position. The parking width is the distance here. Okay, if for example you are parking in an angular way, then your parking width will be the distance that is parallel to the curb. Okay? And the stall width is this distance. It's the width that you allocate for each car. And there's a relation between the stall width and the parking width. Basically, the parking width is the stall width divided by sine of delta. And if this delta, this angle is 90 degrees, you are making a perpendicular parking, then since we know that sinus 90 is 1 degrees, then the parking width is equal to the stall width. Then, depending on whether it is single loaded or double loaded, whether you have a wall or not, and whether you are parking with an angle or perpendicular, then the space that you need to allocate for each module is different. So there are some, again, tables that you guide you how much space you need to allocate for each one of these modules. Let's see one example. This is an example table that shows you how much space you need to allocate for each module. And this table, in order to read this table, basically we have some groups depending on the size of the cars. So in this slide you see group 1 as small cars and group 2 as standard cars, and the table continues in the next slide with larger cars. Okay, so for each type of car you will have different lengths. Then depending on the angle of park, again you will have different values for the width. So in this table the angles are considered as 45, 50, 55 up to 90. Okay, all these angles are provided here. Then for small cars, only alternative for stall width is 8 feet is considered, but for standard cars 8 feet and 6 inches, 9 feet, 9 feet and 6 inches. So different stall widths are considered. Okay, so we have groups for cars, then we have angle of parking, then we have different stall widths, and then depending whether it's a single loaded or double loaded or having walls or not, we have 4 alternative combinations for the modules. So you are going to select, for example, one of these. You will, for example, say that, okay, I'm going to design a module for standard cars having 9 feet with an angle of, let's say, 70 degrees, and we want to use a double loaded module with, let's say, walls on both sides. Then this 60 feet is will be the total width of your module. This is the next slide, continuing with the same table, and here you can see the module widths for the larger cars, and for larger cars the stall widths are 90 feet, 9 feet, 9 feet and 6 inches, and 10 feet are provided, again for different parking angles and different single or double loaded configurations. Let's consider an example to show you how to use this information, how to use these tables to design a parking space. Okay, this is an example from your book, and the example is given like this. We are going to design a new facility, and for this new facility we will design the parking spaces. So in this facility, the expected number of employees is 200. 200 employees will be working here. A survey is conducted, and it said that parking space must be such that a parking space is provided for every 2 employees. So you can combine these two information with each other. 200 employees will be working, and a parking space is necessary for every 2 employees. Again, from a survey, we know that 40% of cars are compact size cars. Okay, so this data is given. You need to satisfy a space or allocate a space of 40% of the total parking space for small cars. Then we want to allocate 5% of total spaces for handicapped employees. We have an available parking space of 180 feet wide and 200 feet deep, and we know that there will be no walls nor walking edges in this parking space. And the question is, determine the best parking layout using a stall width of 8 feet and 6 inches for standard cars. So if you remember the previous table, for standard cars, 8 feet and 6 inches was in the table, so we need to look the table to understand the width of the module. So please spend some time at this point, stop the video here and spend some time here to make a design to satisfy these many parking spaces with these many compact size cars by yourself, and then after working on it, please continue with the next slide. Okay, friends, I know that making a design with only the available information just you have is not easy. Uh, and making such designs requires a lot of time and experience. Without any experience, of course, in the first time you may not be able to come up with a design. And the thing is, there is no single best design. So you may work on this problem by yourself, and your friend works by himself, and then both of you come up with your own design, but which one is the best? So you need to look at some metrics, some criteria to compare these two with each other. Maybe you will look at the space utilization. So both designs, which are different from each other, may satisfy all the requirements of the problem, but one of them can be better than the other one. You need to select it. That's why in the procedure, one step is to come up with alternative designs, and the next step is to select the best design. Okay, so what you need to do in order to solve this question is to collect every information that you have, and then take a piece of paper and a pencil and to make a design. If something is not suitable, then change it and try it and retry it and come up with a plan, and then change your design settings and redo everything and come up with another alternative, and then compare these two alternatives and you will end up with a better design. Okay, for this question, let's consider, what do we know? We know that there are 200 employees, right? And we need to allocate space for every 2 employee. It means that we should have 100 spaces. We know it. And 40% of the total cars is the compact size cars. It means that we need to have 40 for compact cars. But again, be careful. Initially, in the earlier slides, I told you that, okay, sometimes we allocate space for 1.25 employees, 1 parking space. And I told you that why are we allocating 1 space for 1.25? Because we said that maybe each day, not every one of these employees are coming to work. They may be on annual leave, they may be coming sharing with a friend, and etc. Here, we may have that situation as well. So, okay, we have employees, 40 employees with compact size cars, but maybe all of these employees are not coming to work every day with their cars. So that's why if you allocate 40 spaces for compact cars, then you may be making a mistake. That's why what we will do is we will only allocate 30 spaces for compact cars. How did we decide on this 30? Can it be 35? Can it be 25? Yes, of course. If you have data, use that information. If you don't have data, try to make your own judgment and rules of thumbs. Okay. So in this example, we are going to design or allocate 30 spaces for compact cars. Then, okay, we know the total parking spaces. Then we know the parking spaces for compact cars. Then we know that we are going to use double-sided or double-loaded modules, and we need to decide on the angle. And from again previous slides, we know that if you use an angular, let's say, parking space configuration, then it will be easier to make maneuvers. The turnover will be higher and the width of the module will be less. But we also know that the space utilization is much better if you have 90-degree perpendicular parking. So that's why in this question we are going to use double-sided, double-loaded 90-degree two-way traffic. Okay. Again, now we know the number of compact cars, the number of standard cars. We know 90-degree parking, double-sided. So we can go back to previous tables and figures and come up with our necessary space for the cars. For compact cars, we are going to use 90 degrees with configuration, module configuration 4, where we don't have walls and double loaded, and for compact cars with 8 feet and 8 feet. The module width in the table is given as 57 feet and 2 inches. Please go check the table and try to find this value in the table. Again, for standard cars with 90-degree parking with module configuration 4, we are going to use, it's given 8 feet and 6 inches. Then the module width in the tables is given as 66 feet. Okay, now we have some information about the problem and we have some idea for the solution, but the details are still missing. Now we need to make the final layout with all the details, including the space, the actual layout, the space for handicapped people, and the for example, the entrance of the parking space, the aisles, cross aisles, and etc. Okay, we need to design all those details. So the available space is 180 feet by 200 feet. First of all, we need to see if we can accommodate, let's say, 2 standard modules and 1 compact module into this available space. So on the one hand side we have 180 feet, on the other hand side we have 200 feet. You can try both of them. Can we accommodate 2 standard modules with 1 compact module into 180? If it is not possible, then you can try if we can accommodate for the 200 feet. So let's make the calculation. We know that if we make this angle 90 degrees for parking, then the necessary module width should be 66 for standard cars and 57 feet and 2 inches for compact cars. Okay. And since we are planning to have 2 standard modules, we multiply this number by 2 and add it to compact modules so that the necessary space is 189 feet by 2 inches, which is less than 200. So we say that we can accommodate 2 standard modules and 1 compact module into these 200 feet. Okay, then this is the depth. Then what about the width of the space? We have available 180 feet space. Then how many cars can we accommodate in this width? We need to consider that. So in order to do it, again, for compact and for standard cars, we have different stall widths. For compact cars, the stall width is 8 feet. So if you divide 180 by 8, then you can accommodate 22 cars in one side. Okay, so for one side you can accommodate 22, but since we are considering double loaded modules, we will have cars on this side and on this side. So 22 cars here, 22 cars here, which makes 44 cars in one module. Okay? This is compact cars. But for standard cars, the stall width for one car is 8.5. So if you divide 180 by 8.5, then you can find the number of cars that you can accommodate on one side. If you multiply it by 2, then you understand you can calculate the total number of cars that you can accommodate to one module. But since we are planning to have 2 modules, we need to multiply this number by 2 again, and in total we will have 84 cars. Okay, so 84 standard cars and 44 compact cars in total makes 128 total number of cars that we can allocate. And initially we already calculated that we need a space for 100 cars, right? So this number is large, but be careful again still. We said that this is enough for 44 compact cars, but initially we said that we need at least 30 spaces for compact cars, and since 44 is larger than that 30, we say that this design is feasible. And this number 128, this is the initial plan, but when we include the cross aisles, when we include the entrance and exit of the parking spaces into our detailed plan, most probably we will not be able to accommodate these many cars. This is our initial plan, and we need to make the final design. Okay, but here we say that this configuration 4 is currently feasible. Let's continue. So we haven't considered the handicapped requirements yet. Now, in the question, it said that we need a space for at least 5 handicapped cars. Okay, and each handicapped car requires 12 feet of space. So in total, we will require 60 feet of space for handicapped cars. Now, initially our plan is to have 2 standard modules and 1 compact module. Okay? And then what we can do is we can use one of these modules, one row of one of these modules to accommodate these 5 spaces for the handicapped cars. And the rest will continue, will have that standard or compact modules. Okay, so let's assume that we are going to allocate these handicapped cars with the standard cars. So the remaining will be allocated for standard cars. Okay? And if we do that, the remaining part is 180 multiplied by 60 divided by 8.5, which is the width of standard cars. So it means that in this row, where we have 5 handicapped cars, the rest will be standard cars, which is 14 in total. Okay, so let's see our final design. Okay, this is the final solution, final design with all the details. Remember, the width was 180 feet and the depth was 200 feet. And we decided to include 1 compact module and 2 standard modules into this depth of 200. Okay, so this is the compact module, double loaded. This is a standard module, again double loaded, and this is a standard module, again double loaded. Okay, so the total width of this module should be 57.2. The total width of this and this should be 66 according to the table. Then we decided to include the handicapped places for 5 handicapped places into one row of the standard modules. So these are the handicapped places with 12 let's say stall width. and the remaining place for this row is assigned for standard cars, so we can accommodate 14 standard cars here. You see here the entrance of the parking space is decided to be here. Then initially in our plan that we said that we are allocating all these 180 feet to the cars. But in fact, if we do that, if a car parks here, then how can the other cars reach to these parking spaces? Then we need to allocate some space for cross aisles. Okay, that's why we are not fully utilizing this module length. We are losing some space for this cross aisles on this side and on this side. So let's have a look at our final design. Here we can use the hull length for compact sizes, which we can accommodate 22 compact size cars. Here we can only accommodate 18 compact cars because on this side and on this side we are leaving some space for the cross aisle. Here again we can only accommodate 17 standard cars and we leave some space for the cross aisle. The same thing here, okay, only 17 standard cars, 17 standard cars here, and here we have 14 standard cars plus 5 handicapped cars. And this is the entrance and these are the aisles. Okay, so we were able to accommodate these many compact and standard and handicapped parking spaces in the given area. But again, this may not be the best and perfect design, but it is a feasible design and it includes all the requirements. It satisfies all the requirements of the problem. And in order to come up with this final layout, you should try different alternatives, and at the end of it, you come up with this design. Okay, so as I said, it requires some experience and some trial and error. Okay, so this will be the end of this tutorial, and in the next one, we will continue with the personal requirements.